Hey everyone, and welcome back for another deep dive with us. We're going to be unpacking some more complex topics and hopefully distilling them into little knowledge nuggets you can use. Today we are tackling something that has fascinated humanity for generations, faster than light travel.
Oh, yeah.
And we've got a fascinating mix of sources for this one. We've got scientific papers, research grants, even snippets from defense intelligence documents. Our mission today is to figure out if FTL is just a science fiction fantasy or if there's actually a glimmer of scientific reality hidden within all these pages.
Well, it's interesting because the concept of faster than light travel is so ingrained in our imagination, right? Thanks to all these books and movies. But the science behind it is actually very grounded.
Okay, so you're saying it's not all warp drives and hyperspace travel.
Well, those are fun to think about. But there is some real science to this. This all started with Einstein. His theories of special and general relativity, while seemingly imposing a speed limit, the speed of light, they also hint at possible loopholes, maybe some workarounds.
Okay, so Einstein gave us the rule book, but maybe he also left us a few cheat codes hidden within the pages.
I like that. That's a good way to put it.
Right.
Yeah, so for example, Einstein's theory of general relativity suggests that space-time itself can be warped, like distorted by massive objects. And this realization opened up a whole new realm of possibilities. Like, what if we could manipulate space-time, create shortcuts, tunnels maybe, that could allow us to circumvent that speed of light limit?
So we're not talking about like breaking the speed limit, but rather just finding a way to bend the rules of the road.
Precisely. And that is where things like the Alcubierre warp drive come into play. So the idea with that is to create a bubble of space-time around a spacecraft. And this bubble would contract space-time in front of the ship and expand it behind the ship. So it's essentially creating a wave that the ship can ride.
Wow.
It allows it to travel faster than light without technically breaking the speed of light locally.
It sounds like we're talking about surfing on the fabric of reality itself.
It's pretty wild.
But there's got to be a catch. This can't be that easy. What's the catch?
Well, the catch is that creating this warp bubble, manipulating space-time in such a precise and controlled way would require something pretty exotic.
Exotic in what way?
A type of matter.
What kind of matter?
With negative energy density.
Negative energy density. Okay, hold on. My brain needs to catch up here. We all know what regular matter is.
Yeah.
It's the stuff we're made of. It's stars, planets. But negative energy density, that sounds like it's straight out of a science fiction novel.
Yeah. It might sound fantastical, but there are hints that negative energy density might actually exist.
Really?
Yeah. One example is something called the Casimir effect. So the Casimir effect is a real-world phenomenon where negative energy density just arises from quantum fluctuations in a vacuum.
You see, this isn't just theoretical mumbo-jumbo, right?
Right.
Like this Casimir effect, that shows us that empty space itself can have this weird negative energy thing going on. Now imagine harnessing that for a warp drive.
Exactly. It's exciting to think about. It is a tantalizing possibility, but there are limitations too. Because quantum physics principles known as quantum inequalities, they seem to restrict how much negative energy we can actually extract and for how long. So that's kind of a bummer, but there is research into things like squeezed vacuum states and the Dirac field, which offer some potential ways to maybe overcome these limitations. Named after Paul Dirac, he's the physicist who first theorized the existence of antimatter. So his work, surprisingly, has relevance to understanding the quantum world and potentially manipulating it for something like, a warp drive.
So while negative energy density might be real, harnessing enough of it to power a warp drive, that's still a major hurdle.
That's right.
Okay. What about wormholes? Aren't those like theoretical shortcuts through space-time?
Yeah, exactly. So wormholes offer a different approach to faster than light travel.
Okay.
Instead of trying to move faster than light through space, the idea is to bend space itself.
Oh, okay.
To create a tunnel or a shortcut that connects 2 points.
Oh.
Imagine folding a piece of paper so that 2 points on opposite ends touch. That's essentially what a wormhole would do.
So you could step through a wormhole and instantly travel vast distances without actually exceeding the speed of light.
Yeah, that's the idea, yeah.
Okay.
But creating and stabilizing a wormhole that's large and stable enough for a spacecraft, that would likely require, well, you guessed it, exotic matter with negative energy density.
It seems like this exotic matter and negative energy density, those are really the keys to unlocking all these mind-bending possibilities.
Yeah, they seem to be pretty crucial.
But let's just say we could somehow generate and control this exotic matter. Wouldn't the engineering challenges of actually building and operating a faster-than-light spacecraft, wouldn't they just be astronomical?
Oh, absolutely. You're talking about manipulating the very fabric of reality,
Yeah,
right?
right.
Withstanding these crazy forces, the stresses, and then developing propulsion systems capable of generating and controlling like unimaginable amounts of energy.
It sounds like we're still very firmly in the realm of theoretical physics here.
For now, yes.
Yeah.
But the great thing about science is that it's constantly pushing the boundaries of what we know and what we believe is possible. So, new discoveries like the confirmation of dark energy, that's breathed new life into FTL research
Yeah.
because it suggests there might be even more to the universe than we currently understand.
Oh, so dark energy.
Yeah.
That mysterious force that's like accelerating the expansion of the universe. You're saying that could potentially be the key to unlocking FTL travel.
It could be, yeah. It's one of the exciting avenues scientists are exploring.
This is all incredibly fascinating.
Yeah.
But I have to ask, why should we even care about faster than light travel?
Yeah.
Like beyond just, how cool it is, what are the practical implications? What's the end goal here?
That's the question, isn't it?
Yeah.
The implications of achieving FTL travel are pretty huge, I think.
Really?
It's not just about zipping around the cosmos. It's about potentially reshaping our understanding of time and space and our place in the universe.
Okay, so give me some examples. Like what kind of doors would this open for humanity?
Well, imagine a future where we could reach other star systems within a human lifespan.
Wow.
We could actually study those planets,
Oh,
search for alien life,
yeah.
maybe even find new homes for humanity amongst the stars.
It'd be a game changer, allowing us to break free from the confines of our solar system and venture into the vastness of the cosmos.
Exactly.
But there's also the potential for some unintended consequences as well, right? We've seen enough science fiction movies to know that tampering with time and space can lead to, some pretty messy paradoxes and unintended consequences.
Oh, for sure. And that's actually a very important aspect of this whole discussion, are the ethical implications of FTL travel.
Right.
Because we need to consider things like those time travel paradoxes you mentioned, the impact on any life forms that we might encounter, and of course the potential for misuse of such powerful technology.
It sounds like we're not just talking about a technological challenge, but also like a philosophical and ethical one as well.
Precisely. But before we jump into those big topics, I think it's good to understand how this whole fascination with FTL travel even began
Okay.
and what role science fiction has played in shaping our perceptions and expectations.
Right, because FTL travel has been a staple of science fiction for decades. And it's definitely influenced, like you said, our collective imagination. But where did the scientific exploration of these FTL concepts begin? Was it purely inspired by like these fictional portrayals? Or did it kind of emerge independently?
Well, that's where it gets really interesting. While science fiction definitely played a role in popularizing these ideas, the scientific exploration of FTL travel actually has roots in theoretical physics.
Oh, really?
Yeah, and the publication of the first traversable wormhole article in 1988, followed by the first warp drive paper in 1994, that really marked a turning point. Because those groundbreaking works, they were grounded in Einstein's theory of general relativity, and they demonstrated that FTL travel wasn't just a fantasy, but a theoretical possibility
Wow.
within the framework of established physics.
So Einstein's own theories, the very ones that seem to impose the speed of light as an unbreakable barrier, also open the door to the possibility of FTL travel.
It did, yeah. It's such a great example of how scientific exploration often leads to really unexpected discoveries.
New avenues of inquiry.
Exactly. And then those early papers on wormholes and warp drives,
Yeah.
those sparked so much excitement, so much discussion within the scientific community. And then in 2009, the first scholarly book compiling these and other breakthrough propulsion concepts was published. And it brought together physicists, mathematicians, engineers, even philosophers to really explore the scientific, technological, and philosophical challenges of FTL travel.
It sounds like this field of research was really gaining momentum.
It was, yeah.
But were there any concrete efforts to actually investigate the feasibility of FTL travel? Like any experiments or research programs that were dedicated to this goal?
Well, there were a few.
Okay.
And one notable example was the NASA Breakthrough Propulsion Physics Program,
Okay.
which ran from 1996 to 2002. And this program was really groundbreaking in its scope because it investigated a wide range of those unconventional propulsion concepts. including warp drives, wormholes, and other ideas that at the time seemed pretty out there.
So NASA was actually willing to invest in research that sounded like it was straight out of Star Trek.
They were. And while the program, it didn't achieve the ultimate goal of actually demonstrating practical FTL travel, it made significant contributions to our understanding of these unconventional propulsion concepts.
Hmm.
It helped to identify some of the key challenges,
Okay.
propose potential solutions,
Yeah.
and really lay the groundwork for future research.
It sounds like even though they didn't crack the code of FTL travel, they at least helped to legitimize this field of research, to show that it was worthy of, serious scientific inquiry.
Exactly. And since then, there has been a resurgence of interest in FTL travel,
Hmm.
fueled in part by new discoveries in astrophysics and cosmology, particularly the confirmation of dark energy.
Right, dark energy.
That mysterious force that's, accelerating the expansion of the universe. But how does that relate to FTL travel?
Well, the nature and properties of dark energy, they're still largely unknown.
Right.
But some physicists have theorized that it might be the key to manipulating space-time in ways that could enable faster-than-light travel.
Oh, so dark energy could be that exotic matter, that source of negative energy density we need to create those warp bubbles and wormholes.
It's a possibility.
Wow.
The people are actively exploring.
Hmm.
And the discovery of dark energy has definitely opened up this whole new realm of speculation and research in this field.
It's amazing how one discovery can completely change our understanding of the universe and open up all these new avenues of exploration.
I know. It's pretty remarkable.
Has there been anything else, any other discoveries that contributed to this renewed interest in faster-than-light travel?
Well, another significant development has been, recognizing that some of the fundamental principles that seem to rule out FTL travel might not be as ironclad as we once thought.
Okay.
So, for example, studies suggest that certain quantum states, like those squeezed vacuum states and configurations of the Dirac field that we talked about, they could potentially circumvent those limitations.
So there might be loopholes or exceptions to the rules that we thought governed the universe.
Exactly. And there's even been some, tantalizing experimental evidence,
Oh, wow.
though still debated,
Okay.
that hints at possible violations of these quantum inequalities.
It sounds like we're on the cusp of a new era of exploration where the boundaries between science and science fiction are becoming more and more blurred.
In a way, yeah.
Yeah.
But as we push those boundaries, it's super important to remember that science fiction often takes liberties with scientific accuracy
Oh, of course, yeah.
for the sake of storytelling. And while those stories can inspire and motivate us, we need to ground our expectations in the realities of current scientific understanding.
So it's about finding that balance between, embracing the wonder and excitement of the unknown.
While also remaining grounded in, a rigorous process of scientific inquiry.
Exactly. Now, before we dive into the specific arguments for and against prioritizing FTL research, I think it's important to consider, the influence of public perception and the role of science fiction in shaping this entire discussion. Because the public's interest in interstellar travel has definitely been sparked by things like the discovery of exoplanets,
Right.
those announcements of privately funded mission plans,
Right.
and, of course, those explorations of FTL concepts in science fiction.
Yeah, I could definitely see how those discoveries and stories would capture the public's imagination. There's something so captivating about the idea of, exploring other worlds and pushing the boundaries of what's possible.
For sure. And science fiction has played a huge role in nurturing that sense of wonder. You look at works like Star Trek and Star Wars. They've introduced these concepts like warp drives and hyperspace into the cultural lexicon, making them synonymous with faster-than-light travel in the public mind.
Mm-hmm.
They've provided a glimpse, however fantastical, of what might be possible if we could break free from those constraints of our current understanding of physics.
They've inspired, generations of scientists and engineers and dreamers to consider these possibilities.
It's totally.
And to push those boundaries of what we believe is achievable.
Exactly. And so, this interplay between science and science fiction has created this fascinating feedback loop where each inspires and informs the other.
Right.
But as we've been discussing, it's important to be mindful of the distinction
Okay.
between science and science fiction
Yay.
to avoid unrealistic expectations and to appreciate those complexities of the scientific process.
It's about harnessing that power of imagination
Yes.
while remaining grounded in those realities of scientific inquiry.
Yeah.
So with all that in mind, I think it's time to tackle the big question.
Okay.
Should we prioritize research into FTL travel with all of its uncertainties and challenges? Or should we focus our resources on those more pragmatic, near-term alternatives for space exploration?
Well, that is the question at the heart of this whole discussion,
Yeah.
and it's one that will likely continue to debate for many years to come.
So let's get right to it. Who are the champions of FTL research, and what are some of their strongest points?
The people who are proponents of prioritizing FTL research are kind of a diverse bunch.
Okay.
You've got your theoretical physicists, cosmologists, engineers, a whole lot of just passionate space enthusiasts.
Yeah.
What really unites them is this grand vision. Okay.
Of humanity becoming this interstellar species capable of traveling between stars and experiencing the universe on a scale that's just unimaginable now.
It's a vision that's definitely rooted in our desire to explore, to push those boundaries, discover what lies beyond the familiar.
But for these folks, it's more than just like a romantic notion.
Oh, yeah.
They actually view FTL travel as a necessity for survival,
Oh, wow.
a technological leap that is crucial for the long-term survival and prosperity of humanity.
Wow.
And their argument really hinges on the vastness of those interstellar distances. Because even with significant advancements in like conventional propulsion technologies, like fusion-powered spacecraft, we're still talking about travel times that span generations.
I get it. A journey that takes hundreds or even thousands of years to complete, it just isn't feasible.
Right.
At least not with, our current understanding of human biology and psychology. It's hard to even imagine maintaining the public support and funding for a mission that would take longer than the entire recorded history of human civilization.
Exactly.
So that's the thing. They think that FTL travel is that game changer. The only way to bridge those massive interstellar distances and make human exploration of the universe a realistic possibility.
So we're not talking about just incremental improvements in speed here, but a fundamental paradigm shift in how we approach space travel.
Yes.
Instead of multi-generational voyages, it'd be like hopping on a plane and flying to another country.
Exactly. We could reach other star systems in a matter of days or weeks or months. Rather than centuries or millennia, we could send probes to study those planets up close, search for signs of life, gather data that would just revolutionize our understanding of the universe, and maybe, just maybe, establish colonies on other planets.
Safeguarding the future of humanity beyond the confines of Earth.
Yes.
It's a bold vision.
It is.
One that speaks to our sense of venture.
For sure.
Our desire to push those limits of human achievement. But it's also incredibly ambitious, bordering on science fiction.
It is, yeah.
Manipulating space-time, harnessing exotic matter, rewriting the rule book of physics as we know it.
There's no denying it. FTL research is high risk, high reward. It's a gamble. It's a shot in the dark.
But you're saying for the proponents, it's a gamble worth taking.
Exactly. Because the potential payoff is so big.
Okay.
They argue that even if the odds of success are very small, we can't afford not to pursue it. It's about pushing the limits of what we believe is possible, embracing the unknown, striving for something truly extraordinary.
It's about daring to dream big and not letting our current limitations define what we believe is achievable. But I'm also aware that there are strong voices on the other side of this debate, those who advocate for a more pragmatic approach.
There are, yeah.
Yeah.
And they make some really valid points, too. These are individuals ranging from scientists and engineers to policymakers and even some science fiction authors.
Okay.
And they argue that while FTL travel might be fascinating, it's just too far-fetched, too resource-intensive to make it our top priority right now.
So they're not necessarily saying that FTL travel is impossible,
Right.
just that it's not a practical goal to focus on at this point in time.
Exactly.
Okay, what are some of their main concerns, though?
Well, one of their primary concerns is the cost, the sheer cost of FTL research. Because we're talking about exploring these concepts that require us to just push the boundaries of physics, engineering, material science.
To levels we haven't even begun to comprehend.
It would require massive investment in research and development, potentially diverting resources away from other important scientific endeavors.
Right.
And even then, there's no guarantee of success.
It's like pouring all of our resources into developing a perpetual motion machine when there are, more pressing issues to address.
Exactly. And the proponents of a more grounded approach, they argue that we need to be more cautious. We should focus on the low-hanging fruit, the technologies that are within our grasp
Okay.
that can deliver tangible benefits in the near future.
Like what? Give me some examples of these more pragmatic alternatives.
Okay, well, one obvious example is just the continued exploration of our own solar system.
Okay.
We've barely scratched the surface
Yeah.
of what there is to discover right in our cosmic backyard. There are still countless mysteries to unravel,
Oh, yeah.
from the icy moons of Jupiter and Saturn to the distant Kuiper Belt.
It's a reminder that there's still so much we can learn and achieve right here in our own corner of the galaxy.
Absolutely. And then there's that ongoing effort to establish a permanent human presence on Mars.
Yeah.
Now, that would be a monumental achievement,
Hey, what?
a testament to human ingenuity and our ability to extend our reach beyond Earth. And it would also serve as a stepping stone for future missions to other destinations within our solar system.
It's a goal that's both ambitious and achievable, and one that would capture the public's imagination
For sure.
and inspire, future generations of scientists and explorers.
Exactly. And then beyond our solar system, there's the development of those advanced propulsion systems
Okay.
that could significantly reduce travel times, even if they don't achieve faster than light speeds. Fusion-powered spacecraft, for instance.
Uh-huh.
They could potentially reach a significant fraction of the speed of light, enabling missions to nearby stars within a human lifetime.
So it wouldn't be instantaneous travel like in science fiction,
No.
but it would be a significant leap forward
It would, yeah.
compared to our current capabilities.
Exactly. And the research and development of fusion technology, that would have those spin-off benefits in other areas like energy production here on Earth. So for these people, a more pragmatic approach to space exploration, it's about balancing ambition with practicality, pursuing goals that are challenging but attainable, making incremental progress, focusing on the journey, not just the destination.
It's a perspective that emphasizes responsible stewardship of resources
Absolutely.
and making choices that can deliver tangible benefits in the near term. It's also a reminder that progress in space exploration, as in any field, is often a marathon, not a sprint.
Well said.
Right.
Now, it's important to remember that this debate isn't a simple either choice. It's not about completely abandoning FTL research or vice versa.
It's about finding that right balance.
Yes.
Allocating those resources wisely and pursuing, a portfolio of research and development efforts that spans that spectrum of ambition and feasibility.
Exactly. And that balance will likely shift over time as our understanding of the universe evolves and new technologies emerge. Like if we have a major breakthrough in our understanding of dark energy, or the manipulation of space-time, it might then make sense to really increase that investment in FTL research.
And conversely, if we encounter unexpected challenges or roadblocks in our pursuit of FTL travel, it might be prudent to refocus our efforts on those more pragmatic goals.
Exactly. The key is to remain flexible,
Right.
to adapt,
Yeah.
and to make informed decisions.
It's also crucial to engage in those open and honest discussions about the potential benefits, the risks, the ethical considerations, because ultimately, this is a decision that will shape the future of humanity and our place in the cosmos.
Well, we've definitely explored the arguments for and against prioritizing FTL research, and we've highlighted the importance of finding that balance. But there is another crucial dimension that we need to discuss:
What's that?
the ethical implications of FTL travel. We're not just talking about a new mode of transportation. We're talking about potentially altering the fabric of space-time,
Right.
traveling to distant worlds, and perhaps even interacting with other intelligent life forms.
Exactly.
So the ethical considerations here are really significant, and they deserve careful scrutiny.
So let's dive into those thorny questions. What are some of the key challenges we might face if we achieve faster than light travel?
Well, one area with a lot of potential is the development of, increasingly advanced telescopes and observatories. We've already seen the incredible power of the James Webb Space Telescope.
Yeah, those images were amazing. They gave us a glimpse of the universe as it existed, billions of years ago?
Yeah,
But you're suggesting we can go even further.
I think so.
How?
Imagine telescopes so powerful that they can directly image exoplanets.
Exoplanets, so those are worlds orbiting distant stars?
Yes.
Wow, to actually see an alien world with that level of detail would be mind-blowing. But what kind of technology would we need to make that a reality?
Well, we'd need telescopes with massive mirrors, perhaps even arrays of interconnected telescopes, all working together to gather enough light from these distant worlds.
Yeah.
And then also advanced adaptive optics would be crucial to compensate for the distortions caused by Earth's atmosphere.
Okay.
And then we need incredibly sensitive instruments to actually analyze that faint light from those exoplanets, actually extract some meaningful data.
It sounds like a monumental engineering challenge.
It really is.
But if we can overcome those hurdles, the payoff would be enormous.
It would change everything. And it's not just about visual observation either. We could develop sensors that detect other forms of radiation,
Like what?
like radio waves, X-rays, gamma rays, revealing hidden features that are invisible to our eyes.
So instead of just looking at the universe in visible light, we'd be creating a multispectral view, uncovering hidden structures, energetic events, and maybe even signs of advanced extraterrestrial civilizations.
That's right. That's the beauty of it. By expanding our observational capabilities, we're not just seeing more. We're seeing it in different ways.
It's like developing these cosmic senses, ways of perceiving the universe that go beyond the limitations of our human perception.
That's a great way to put it.
Yeah.
And, it's not just about building bigger instruments either. We can also leverage the power of things like AI and machine learning to analyze the massive amounts of data that these instruments collect.
Right, AI can be our partner in exploration, sifting through all that data, identifying patterns, making discoveries that we might have missed otherwise.
Exactly. It's this really powerful synergy of human ingenuity and artificial intelligence, working together to solve the mysteries of the universe.
This is all incredibly exciting. But what about actually experiencing these distant worlds? Seeing those images, analyzing the data, that's one thing. But actually feeling like you're there, immersing yourself in the environment.
Yeah.
That'd be a whole other level of exploration.
That's where things like virtual reality and augmented reality come into play.
Okay.
Imagine putting on a VR headset and you're transported to the surface of an exoplanet. You're walking on its alien terrain. You're feeling its atmosphere, gazing up at its unfamiliar sky.
Wow. To experience a truly alien world in such an immersive way, it would be like stepping into a science fiction novel, but with the added realism of actually feeling like you're there.
Exactly. And as those technologies advance, the experiences are going to get even more realistic by incorporating sensory feedback, haptics, and maybe even ways of simulating the gravitational pull of other planets.
So I could feel the weight of my body change as I step onto a planet with a different gravitational force.
You could. It would be incredible.
It would add a whole new dimension to the experience of exploring other worlds.
And it's not just about passive exploration either. We could use those virtual environments to conduct experiments, test hypotheses, train astronauts for future missions.
It's like creating a virtual sandbox for space exploration.
Totally.
A safe and controlled environment where we can push those boundaries of understanding without the risk.
Yeah, exactly.
Yeah.
And as our understanding of consciousness and the nature of reality evolves, who knows what other possibilities might emerge?
Okay, now you've really piqued my curiosity. What do you mean by that? Are we talking about like astral projection? Some kind of out-of-body experience?
Well, this is definitely getting into more speculative territory. But some physicists and philosophers have theorized that consciousness might not be confined to the physical brain.
So you're saying our minds could potentially exist independently of our bodies?
That's what they're suggesting, yeah.
That's a mind-boggling concept.
It is, and there's growing evidence from fields like quantum mechanics and neuroscience, suggesting that consciousness might be more fundamental than we thought.
So if consciousness can exist beyond the physical body, could we potentially explore the universe with our minds?
It's a possibility.
It sounds like something straight out of science fiction,
It does.
but it's also incredibly intriguing.
Perhaps one day we'll develop technologies or techniques that allow us to project our consciousness across these vast distances, experience other worlds, connect with other beings in ways we can't even imagine right now.
It would be like, what, a form of consciousness-based space travel, where the limitations of speed and distance just become irrelevant?
Exactly. And it might be that this form of exploration, this expansion of consciousness, it's ultimately more profound,
Right.
more transformative than simply reaching another star system.
It's about connecting with the universe on a deeper level, expanding our awareness, and perhaps even discovering that the true boundaries of exploration lie not in the physical realm,
Right.
but within our own minds.
The quest for knowledge, that desire to connect with the cosmos, that's ultimately a journey of self-discovery and transformation.
It's a beautiful and inspiring thought. It makes you realize that the universe isn't just something out there waiting to be explored. It's something we're already part of, and that the true journey of discovery begins within ourselves.
Well said.
Well, I think we've covered a lot of ground in this deep dive. We've explored the science, the technology, the ethical dilemmas, the philosophical implications of faster-than-light travel. We've debated the merits of prioritizing FTL research, and we've ventured into those alternative paths to interstellar exploration, from advanced telescopes to virtual reality, to the mind-bending possibilities of consciousness expansion.
I hope you've enjoyed this journey as much as we have.
I know I have.
And if you're as fascinated by the universe and the quest for knowledge as we are, don't forget to like and subscribe.
Yeah, for more curated deep dives into captivating subjects. Until next time, keep looking up,
Keep questioning
keep exploring.
and keep wondering.